Hi, this is our third partial project. Our teacher is Guillermo Rodriguez Valenzuela. We are Luna Reina, Joan Delgadillo, Sofia Benavides, Daniela Mejia, and Valeria Gonzalez. As we have presented, the problem is an ellipse in general form that we're going to convert it into standard form. So first we're going to start by grouping the terms that are dividable. The x with the x and the y with the y. So now we're going to complete the square first with the x terms and then with the y term. We have to add plus 1k plus 2k2 and for the j we're going to add plus k2 minus k2. So what is k1? K1 is the b term of the x that it's going to be parentheses, the root squared of 5 divided by 2 and squared. So that's gonna give us 5 fourths. Then we're gonna replace the Q1 with that. 5 plus 5 fourths and minus 5 fourths in the x terms. So K2 is the same, but in the y terms. It's going to be the b term in the y divided by the half in this squared. So that's going to give us 1 under 256. So we're going to replace that in the K2 in the y term. Now that we have this, we're going to factorize it into binomials, like this way. We have x minus, we're going to add the root squared of 5 fourths. And this we're gonna add it to the square plus 4 plus y plus the root square of 1 under 16 to the square. This is equal to 7. Now we need to pass the 5 fourths to the other side. This we have to multiply it and pass it to the other side, and this is gonna give us plus 1 under 64. Then we have to resolve this, and the equation is gonna be like this: x minus 5 under 2 at the root square plus 4 parentheses y plus 1 under 16 to the square equal to 524 under 64. So now we need to normalize the expression by dividing these terms. So it's going to be 524 under 64, and the formula is gonna give us this: x minus the root square of 5 under 2 to the root square, and all of this is going to be under 524 under 64. We're gonna add a plus, and then we have to put the y terms, 4 parentheses y plus 1 under 16, these to the root, these to the square, Then we're gonna add all this in a division that is gonna be the same, that is 524 under 64, that is gonna give us plus, give us an equal to 1. Now that all this equation is normalized, we need to find the denominators. We're gonna put the same equation under 64 under 524 plus the same equation for the y to the root square, and then we're gonna have to add 256 under 524 equal to 1. So now we get this to a standard form. And the equation or the formula is parentheses x minus h to the square under b2 plus g minus k to the square under a2 equal to 1. Now we can notice that this is bigger than the other one. So we can notice who is the a2, and now that we have the stand form, we can resolve this. So now we're gonna find the vertices and the covertices. So we can notice what the center is, and we have a vertical ellipse. So the A value is gonna be 16 under 23, and the B value it's gonna be 8 under 23. So the vertices are defined and find the expression that is root square of 5 under 2, comma, minus 1 under 16 plus 16 under 23. That is gonna give us this. For the vertex 2, we're gonna do the same, but we're gonna change the sign to minus. So as you can see, these results give us the coordinates for the vertices. So now we have to get the values of the covertices. That is gonna be the root square of 5 under 2 plus 8 under 23, comma, minus 1 under 60 or under 16, sorry. And for the covertices 2, it's gonna be the same, but also we're gonna change the plus for a minus on the 8 under 23. This is our result, and this is our references.